All right, so good evening, everyone. Thank you for joining. So, today we are going to start the first session on the new product development series, which is the faculty development program. So, we will wait for 2 more minutes for other participants to join, and then we will start the session shortly. So, good evening to all the participants. So, we will be starting the session in about 1 minute. So, thank you for joining today's session, which is the faculty development program on new product development. So I am sharing my screen now. Let me know if it is visible. Is my screen visible?
No, sir. Yes, visible, sir.
Okay, sir. Okay. So briefly, we will start the introduction to the product design. But before that, let me briefly introduce myself. I am Nikhil Chaitanya. I am the founder and director of Namoona Enterprises Private Limited. So I have 4 years of experience in new product design and development. I previously worked with TCS, Infosys, and also I worked with Hindustan Aeronautics Limited as a junior specialist. So my background is mechanical engineering. I completed my BTech in 2017, and I also completed my MTech in machine design from Andhra University. And I'm also the PhD research scholar here in IIT Hyderabad. So we will quickly skim through the introduction to the product design. So product is anything which has a functional value to the user. So it can be various categories like software products or hardware products. So some examples of software products are Google Chrome, Adobe Reader, Microsoft Word, YouTube, Amazon Prime. These are some examples of software products. And we will be mainly focusing on hardware products as part of this FDP. And in hardware products, we can broadly classify them into 4 categories. There are many other categories. but mainly we are dividing them into electronics, home appliances, automobiles, and kitchenware. So product development workflow. So it starts with the background research. So first we will do the market survey and hear the voice of the customer, and we will analyze the competitors and what are the existing products available in the market, and then we will do some benchmarking. Benchmarking means for the particular feature which is the best possible product which is available in the market, that is called benchmarking. And once we benchmark the product, we start with the tear down analysis, which is nothing but the reverse engineering of the product. And we try to do the fast diagram, so functional analysis of each and every component of the product. And then we will draw a quality function deployment diagram. And once we analyze the products which are already available in the market, we start with brainstorming. So brainstorming is nothing but we develop the concept sketches, and initially we do the concept screening. So typically the design field, so mainly the mechanical design field or any product design field. So that it is a separate branch of design engineering wherein your job is to develop the concept of the sketch or the rendering of the sketch. And based on the requirement, we will do the concept development. And once the concept is developed, we further develop in more detail using the CAD modeling and finite element analysis, and modifying the product, modifying the design based on the stress analysis. And we will also do the value engineering of existing product. Value engineering is nothing but we try to maximize the value which is being provided by the product, and we will try to minimize the cost. And we will do design for manufacturing considerations. So ultimately we need to manufacture the product and release it into the market. So the manufacturing constraints also we will bring in, and we will develop the first prototype. So once the CAD modeling is developed, we develop the drafting for it, which will go for the prototyping purpose. We will list out all the bill of materials, and there are two types of prototyping. One is the visual prototyping and another is the functional prototyping. In visual prototyping, the main purpose is to analyze the look and form of the product, and it is not having any functional value or the complete functioning of the product. So in visual prototyping we will only use for how the product looks like and how the product feels. And in functional prototyping we also incorporate all the functionalities. Let's say for example it is a mobile phone, so in visual prototyping only the body of the mobile phone is developed, whereas in functional prototyping the touch screen of the mobile phone, the audio jack of the mobile phone, the speaker of the mobile phone, microphone, camera, all those things will be taken into consideration. And finally we will do the product testing, and we will do cost benefit analysis, business case analysis, how much business we can generate and what will be the manufacturing of it. We will do the manufacturing review from all the manufacturing related constraints, and we will take the product approvals mainly for if it is a pharmaceutical product, then we need to take the approvals of pharmacy industries such as FDA. And if it is a children toy, then we need to consider the safety aspects of the children toy, which should not create any harm to the children. And if it is a food product, then we need to take the proper approvals like FSSAI, and similarly all those product approvals we will take. And finally we will do the product launch. So as a mechanical engineer, our job will be in throughout all different stages. So we need to do the tear down analysis of background research, and we will extract the functionalities of the existing products in the market, develop the CAD model, and do the finite element analysis. So exclusively finite element analysis or CFD, those things itself is a big branch of mechanical engineering, wherein your job is to find the stress analysis. And In the manufacturing also, there is a huge role of mechanical engineering. So in developing the tools for manufacturing, developing the prototype. So and here are some of the examples of tear down analysis. So tear down analysis is nothing but we identify what are the individual parts of the final product and what is its function, how is it working. Let's say this is the example of a washing machine. So you can see the various parts of the washing machine, like front panel is there, the tub which rotates the clothes, that is there, the motor is there, the motor is driving the tub using a belt drive, and there is a water pump which pumps the water. So there are various components. So typically you will be reviewing all the parts of the competitor's product, which is called as tier 1 analysis, and then you will try to find for opportunities for improvement. So in order to be successful in the market, you either need to reduce the cost or increase the functional value. Let's say the example of a washing machine, if you are developing some sensors which will sense the water level, or if there are some sensors which will say that okay, the cloths are ready now, you can remove it, or if you can make the machine more smart, so that without less human intervention, the machine is automatically switching on and automatically switching off. Such type of additional things are coming up in the market, so that you also need to take care. And this is another example of a laptop. So laptop is having various components. So we will tear down all the components and then try to understand what is the function of each component. Let's say what is the type of a screen being used, what is the type of memory, what is the type of electronics, what is the type of cooling, what is the processor, and how are they embedded in the laptop body, and what are the peripherals, like how many USB charging points you want, how many HDMI cables you want, how many audio jacks you want, those things, and how much battery backup is required, whether it is for 2 hours, 4 hours, or whatever it might be. Based on that, you will develop the battery of the laptop. And I'm just showing the example of various products. Mainly, our country is now mainly focusing on reduction of imports of electronic components. So, reduce the dependence on buying from China, and mainly we are focusing to develop all the electronics and all the things within our country. So, this is an opportunity for mechanical engineers to develop better products, and which will help our country to develop in a more an advanced manner. And this is another example of the trimmer which we use to shave our face. So trimmer is also having various components, like one is the battery is there, and then the vibrator shaker is there, and another motor is there, and blades are there. So these type of what you can do is you can find some products in the market which are affordable to you, and then you purchase them and you try to dismantle them, do the tear down analysis. And this is another example of a computer mouse. So it is having some buttons, it is having some electronics, it is having the led, it is having those things. So as an engineer, we should not only look at products as a user, we should also try to look at what are the various things that went into realization of the product. So you should think like an engineer, you should think like a design engineer, like what should be the shape of the mouse, what should be the manufacturing constraints, how we can enhance the comfort of the person who is using the mouse. So those type of aspects we need to think about. So this is another product which is a toy remote control car. Mainly, uh, we are trying to develop the toys within our country and reduce our dependence on China. So this is another example wherein a lot of engineering goes into make manufacturing. So mainly the electronic toys are not being manufactured in our country. So that is the sad reality, and I hope that more awareness will be spread so that we can become self-reliant in the toys industry. So you can see that there are electronic components are there, some battery components are there, some plastic components are there. So you can, so as part of the workshop, I will also show you some of the practical examples by developing them using Fusion 360 software. So this is the overview of product design, and like in at the end of the session I will open the Q&A session. So if you have any questions you can ask, and I will share one more presentation. Please be on the online. So this is the functional analysis and system technique. So that is called as a fast diagram. So in the tear down analysis, it is part of the tear down analysis, this fast diagram. So mainly we identify the each functionality of the component by a combination of verb and a noun. So left to right will answer how it is done, and right to left is answered by why it is done. So that is the functional analysis fast diagram. So let's say this is the example of a pencil. So left to right. So what is how it is done? So you want to share some ideas. To share the ideas, you will draw some marks with using the pencil. And how you are making the marks, that is the by holding the lead. And similarly, you want to erase the whatever markings you have done with the pencil. So to achieve that, you need something to hold the eraser. So like that, each and every function of the product is described with a combination of verb and a noun. So the first word is the verb and second word is the noun. Like that, you analyze the parts. And coming to the value engineering, value is nothing but functional satisfaction achieved divided by the cost. It is not always reducing the cost. You can also enhance the value by increasing more functionalities. So previously, if you take the example, mobile phones were only used for communication, that is only calls and SMS were there. But later the mobile phones have evolved into surfing the internet, watching videos, and so many other things have been incorporated into a mobile phone. So that is nothing but increasing the functionality of the mobile phone. So and again, previously Bluetooth and Wi-Fi were not there, and later on the functionality to share various files using Bluetooth driver came into picture. And similarly, if you take earphones for example, previously you had to plug in that aux cable into the mobile phone to listen to the songs, but later Bluetooth came, wherein without the need of the cable you can directly listen to the songs by using the Bluetooth. So that is nothing but enhancing the functional value of the product, and also simultaneously reducing the cost of the product. So if you take previously uh, the initial smartphones, they were costing around 15,000 rupees to 20,000 rupees. That is in the beginning of 2012 2013, that is around 12 years before. But now the smartphones are available at 6,000 rupees or 7,000 rupees also. So that is nothing but a lot of engineering went into it, lot of developments happened, and economics of scale. So what are the aspects to reduce the cost? So smaller size, less material, ease of manufacturing, less number of fasteners, less number of parts, or ease of assembly or ease of tooling. In these many aspects, you can focus and try to reduce the cost of the product. So we should not compromise on the functional aspect. So previously, reducing the cost is not by using a cheaper quality materials into the product. We have to ensure that it is functioning properly, and we have to find out the ways in which we can reduce the cost. So tier down analysis and value engineering go hand in hand. So firstly, we will select a product of interest, and then we will tear down the product into individual parts, and then we will do the functional analysis on that, and then we will look for cost reduction opportunities, and then we will do the modification of the designs. So mainly if you take the example of automobile industry, so there is something called as benchmarking. So the automobile company will have the central R&D team where they will buy the products of competitors. Let's say in our country there are so many cars uh, which are manufactured by various companies. Let's say Maruti Suzuki, Hyundai is there, Toyota is there, so many other companies are there. So for example, if a new model is released by Hyundai, so what Maruti company will do is it will buy the car of Hyundai, and then it will divide the components. It will separate them using the tear down analysis, and it will find out what innovation that company has done. It is properly legal to do such type of analysis. So they will buy the competitor's product, and then they will try to reverse engineer. So that is happening everywhere in every industry. So previously, the technology for developing touchscreen was first pioneered by Apple, by Steve Jobs, and later Samsung and other companies copied that touchscreen. Similarly, what they will it is a standard engineering practice to buy the competitor's product and try to understand what went into the innovation, and then try to come up with our own innovation. So that is one way to get new ideas. And this is one type of example which we done in our company. So our main focus is in the toy sector. So what we did is we purchased one made in China toy, and then we done the tear down analysis of it. So you can see for each part what is its function we have identified. So like hold the front wing, wheels assembly, floor is there, cover components are there, engine cover, so many other parts are there in this particular toy. So like this we performed the tear down analysis, and then we developed the CAD model for the whole car, and now we started manufacturing this toy within India. So that is nothing but tear down analysis, and this example I already shown. So what you will do is what is the function of each and every part, what is the car body, how many motors are there, how many wheels are there, and what is its function. Like this you will develop a chart. So this is part of the new product development. And if you have any questions till now, you can ask, and we will take a small 5 minutes break, and after that I will go ahead to present to you the CAD modeling. So how you develop the CAD model using Fusion 360. So before we go into the Fusion 360 aspect, if you have any questions you can unmute and ask, and after that we will take a short 5 minutes break, and then we will resume. Any questions? Yes, so that particular car which we mentioned, so whatever was manufactured in China, the cost of the product is coming roughly around 2000 rupees, including all the taxes and import duties. But if we are making within our country using 3D printing, we are able to match the same price. So roughly around 1800 rupees, we are able to develop the car. So actually, the Chinese products they are mainly injection molded. So if you want to develop the injection molding tools and all, it will increase the cost. So we have developed the 3D printed version of it. So I will share about it after the break. So we are able to match the price as of now. And if we go for injection molding, the price will come even more less. So less than 1,000 rupees also we can make the toys.
Sir, one question is there.
Yes, sir.
Sir, you are making a model. It is a manual or sensor based?
Which one? The toy car model one?
The toy, yes, sir.
Uh, yes, sir. It is not a sensor-based toy, sir. It is mainly for making uh, it is like a hobby kit. So you cut down all the trims, and then you try to assemble the various parts of the car, and then you will make the car. So we are currently working on the electronics of the car, uh, which will be controlled by a remote control, or either you can control it using your smartphone. That we are working on it.
Okay. Okay. So basically, you are working in modeling.
Yes, sir. 3D modeling and manufacturing, like using 3D printing. So we are not getting in a large quantity of orders, which so we are mainly printing with the 3D printing, and
Okay.
we
Okay.
will gradually invest into our like injection molded versions also, which will further reduce the cost.
Okay. Okay. Okay, sir.
So we will take a short 5 minutes break, and then we will dive into Fusion 360. So today's activity will be to design the body of a drone. So mainly our focus is not only on toys. So our government is encouraging for development of drones. So we will do a practical design activity using Fusion 360, which I will be sharing shortly. So we will be back by 7:05. Now the time is 7 o'clock. So we will be back by 7:05. Please don't leave the meeting, just be on mute, and then take a break and come back. Thank you. So, hello everyone. Are we back?
Yes, sir.
Okay. So, I will share my screen. So, this was the toy which I was mentioning about. We developed the full scale CAD model of it, and we have also started manufacturing it. So, our manufacturing partner is based out of Pune. So, very soon we will be hosting this on Amazon, which customers can start to purchase. And as part of today's activity, we will be developing the body of a drone. So this meeting is anyway getting recorded. So even if you are not able to follow, you can access the recording and you can learn about this Fusion 360 software. And if you want the license, so we have an educational license with partnership with Vignan's Institute of Information Technology. So we will be able to give you 1 year license for this Fusion 360 software. So this is the interface of the software. Mainly, there are some advantages of using Fusion 360 because firstly, it is free for the students. It is also free for faculty members. And another advantage is that it is a cloud-based software, which means there is no loss of data. So there is a chance that maybe something going wrong and you have lost all your CAD files. So anyway, these will be saved in the Autodesk cloud account. So you can simply sign in with your account and you can retrieve all the designs which you have made. That is another advantage. And lastly, Fusion 360 is also the drafting, analysis, and manufacturing software which you can see. So this is the workspace. Not only design, you can also do it for rendering. You can use it for animation. You can use it for simulation. You can use it for manufacturing and developing the drafting as well. So that's the reason we have used Fusion 360 for a long time. And the first thing which you need to do is set the user preferences once you log into your account. So you click on the account and click on preferences, and then you will go to the general, and in the general you will be using the default modeling orientation. So either it is a y-axis in upwards or z-axis in upwards. So mainly we will be using the z-axis as upwards. So that is one setting, and then we will set the units. So the default units for the design, we have to set the units here. So I will be using millimeters, but you can select either centimeters or meters also, and you can also use in inches or feet, or you can use any custom units as well. But I generally recommend using millimeters as the default units, and then click on OK. And in the any CAD software approach is to create the sketch and then use the 3D features to convert the sketch into a 3D model. So as you can see in the design workspace, this is the sketch option, and in the create menu you have various options like extrude, revolve, sweep, loft. So gradually we will be seeing these features. So the first thing I will be doing is to create the sketch for our drone body. So I will click on the create sketch, and then it will ask to select the plane. So there are three default planes. One is the YZ plane, another is YX plane, and then another is YZ plane. So I will select the XY plane. So once you click on that plane, you will be going into the 2D interface. So you can see that all the 2D commands are getting activated in the software, such as line, rectangle, circle, spline, and so on. So what I will do is I will go to create and I am going to select the center rectangle command, and it is going to ask me to select the center point for the rectangle, and I am going to select origin, and I am going to select the second point for the rectangle wherever it is possible on the screen, and I will click it, and our rectangle is created. And now we have to give the dimensions for this rectangle. So to give the dimensions, the shortcut is to press D on the keyboard, or you can go to create and sketch dimension. From here also you can give the dimensions, and I'm going to select the length of the rectangle. I'm going to give it as 160 mm, let's say. That is the length. And I'm going to select this particular line for the height of the rectangle, and I'm going to enter a value of 160. So 160 by 160 is our base of the rectangle. And then once I am done with the sketch, I am going to click the finish sketch option on the top right hand corner with a green circle. I will click on that, and now we are back into the modeling environment, and there is a view cube. So using the view cube, you can select the view of the object. If you click on home, it is going to take you to the home view, and you can activate various views like top view and then front view, as well as the right hand side view. Whatever view you want, you can select the views like this. And then if I click on the small home option here, which is showing in blue color, it is going to take me to the home view, which is the isometric view. And now I am going to give the thickness or height of this rectangle. So for that, I am going to go to the extrude option. I will click on extrude, and then you can see that the profile has already been selected. If it is not selected, we just have to click on this rectangle like this, and then this is the blue color arrow mark. Using the blue color arrow mark, if you drag the object in the direction upward direction, you can create the 3D object like this, and it is going to ask you the distance, and I am going to give a distance of, let's say, 50 mm, and I will click on OK. And now the base body of the drone is ready. So if you want to see the drone body, it is looking something like this. So it is going to have a central object or central body for which 4 different arms will be attached, and each arm is going to carry the motor which will drive the propellers, and these 4 propellers will help the drone to fly. So now I will create the 4 different arms for this. For that, I want to select a mid plane. So to create a mid plane, you need to go to the construct menu here, go to construct and say offset plane, and you will select the XY plane. To select the XY plane, give a long left click. If you give a long left click, it is going to open a menu like this to select various face or the XY plane. If you click on the XY plane, it is going to select the XY plane, and now using the blue color arrow, you can create an offset plane like this. I want this plane to be exactly in the middle, so I am going to give a distance of 25 mm, and I am going to click on OK. And now you can see that this particular plane is exactly in the middle of the rectangle, and I am going to create a sketch on this central plane which I just created, which is the plane one. And now I want to create a reference geometry. So to create a reference geometry, again go to create and then go to project or include, and then click on project and select this particular face, So now I am going to create a reference for this particular rectangle. And then I'm going to create a line. And I'm going to create some reference lines from the center, one in the horizontal direction and another in the vertical direction. And I'm going to convert these lines into construction lines. To convert it, you just right click on the line and say normal or construction. So the construction lines will be shown in dashed format. If it is dashed or hashed, then it is nothing but a construction line. And now using these construction lines, I am going to create the mirror. So I want to mirror this line. And I'm going to select the mirror line as this construction line. And now the two different arms for the drone are ready. Again, I will go to mirror and I will select these two lines. I want to do the undo here. Use the Ctrl Z to undo it. And now again, by using the mirror, I will create 4 lines like this. So once I am done with this sketch, I will click the finish sketch. So like this, we created the central arms for which the drone will be attached. And now I am going to click on the create, and out of all these options, I am going to select the pipe option. And if you select this line, automatically a pipe will be created like this, and it is going to select either a circular option or a square or a triangle, whatever shape you want you can select. So I am going to select square, and then I am going to give a dimension of 20 mm, and the default operation showing here is cut option. I don't want to cut the body, so I will select it as join and I will click on OK. And now you can see the arm of the drone is ready. I will do the same thing for creating the other 4. I will go to create pipe and I will select the second line and I will click on join by giving a section distance of 20 mm. And similarly, I will repeat the process for creating the 4 arms of the drone. And now the 4 arms of the drone are ready. And I am going to save the design. For now, I will click on save and I am going to give a name for this. So whatever the designs are being saved, it will be saved in your Autodesk account, which is in the cloud. So if you sign out of this account and sign in another system, all your designs will be visible. And now I am going to create the sketch for mounting the motors. I will create 4 different circles. So I am projecting the previous geometry so that I will know where I have to create the circle. So I am going to select the center of my circle as the midpoint of this particular edge. and then I am going to give a dimension of 60 mm, and I will do the same thing. I will enter the value of 60. And I forgot to give the dimension for the first circle. So for that, again you can press D on the keyboard and give the value of 60 millimeters. And now I am done with this sketch. So I will click on the finish sketch. And now what I will do is I will extrude these profiles. I will press Ctrl on the keyboard, and I am going to select all the 4 circles like this. And then I am going to select extrude. So I am selecting these profiles which are not selected previously. And in the objects, you will select the option as joint geometry. And if you click on OK, now the basic structure of the drone is ready. And I am going to click on save. And now I want to create the motors for this. So the advantage of Fusion 360 is that if any of the other geometries are available in internet, you can download them and open it in Fusion 360 and you can develop further. So for that, what I will do is I will go to GrabCAD. This is a website where the various components are available on the library. So people like us have created several designs and they will upload it on this platform. And if you just sign up for a free account, you can download already available models. So what I am doing is for the motor of the drone, I want to see if there is any available model, 3D model of motor, so that I can use it as a standard component. So various drone models are available here. So I want only the motor body. So this is a drone motor. If you scroll down, you will see what are the models uploaded here, whether it is correct or not. You can see that Avenger V3 2812 900 kV brushless motor it is. So the step file is available. So you can simply click on download files. So what I will do is I will download this model and import into Fusion so that I can modify my geometry accordingly. So it is going to take some time. In the meantime, I am going to split this body into 2 parts. I will click on modify, and in the modify I will say split body, and I will select this body, and then I am going to say splitting tool, and I will unhide this plane, the plane which I created earlier. And now you can see that if you expand the bodies, you have body 1 and body 2. So these are the two bodies. So I'm going to rename this as top and bottom. And I'm going to hide the top part. And now what I can do is I can create a shell. So I will click on modify, and I am going to select the shell option. And if I click this particular face, it is going to ask you the shell thickness. I will give a thickness of 2 millimeters, and I will click on OK. And now you can see the shell is being created, and you can create internal components of this drone. So it is almost ready for manufacturing purpose. You can see just by using the shell command how you are able to create the internal cavity of the body. And the same thing I will do for the top part. I will hide the bottom part, and I will unhide the top part, and I am going to do the same thing by creating a shell. Click on shell, select this face, give a thickness of 2 millimeters, and click on OK. And now the top and bottom shells are ready. If you want to see the internal structure, you can go to inspect, you can go to section analysis, and then select the plane which you want to do this for the section analysis. And here you can see how the two bodies are created, the top part and bottom part. And it is going the internal cavity, including the place where you will create the motor, and inside this you will place the motors. And this particular armature is used for drawing the motor cables. So motor is having a cable, that cable will be connected to the central electronics board. I will click on cancel, and I am going to save this design. And let me check if the download is ready. It's still downloading. I will try any other model just to show you how you can standardize your design instead of doing everything from scratch. So this is another model created by someone else of the same drone motor. I will simply click on download. And let's say you want to go for manufacturing. So in the meantime, while it is being downloaded in the background, I will show you how you can start 3D printing this drone body. So for that, you need to select the particular body and give a right click here, and it is going to open up various menu option like this. So you have to click on save as mesh. If you click on save as mesh, you can convert the object into STL file. So whenever you are converting, whenever you want to 3D print something, the first step is to convert the design into STL format, which is the standard triangular language. And by sharing the STL file, you will be able to 3D print the object. If you click on OK, it is going to ask you to give a name for the file and where you want to save it. I want to save it in downloads. And similarly, I will do for the top part. I will right click on the body and I will click on save as mesh. And the unit type you have to keep it as millimeters only. Otherwise, it will be scaled down or scaled up, which you don't want. So the format has to be STL binary. So the recommended format is STL binary. You will select that and you will click on OK. Give this a name. And now you have the STL files. So if you share these two STL files with any manufacturer, they are going to 3D print it for you, which you can start manufacturing. So if you right click on this file and go to properties, it is going to show you it as .stl file, .stl format. So already I have uploaded how to slice the model and how to go for 3D printing on my YouTube channel. So I will mail you those links because it is going to take a lot of time if I start explaining the 3D printing aspect. But if you are interested, we can do a separate session on 3D printing only. So once you convert it into STL file, so I will share some websites where you can get the quotation for it. So one good website is Mechanica 3D printing services. It is based out of Bangalore. So you can get an instant quotation for your file. So you can get an idea of how much it is going to cost you if you want to manufacture this. I will just show you a small live demo. So if you just upload the STL file, it is going to show you the cost for manufacturing it. So I am going to upload these two STL files which we downloaded earlier from Fusion 360. And you need to select the units. The unit has to be in millimeters. So the two files are uploaded. You can see what is the dimension of the part and what is the material and how many pieces you want, and instantly it is going to display the price. So you can start from here and proceed by paying it. So this is an instant method which you can get to know how much it will be costing you for manufacturing it using 3D printing. So there are some other companies which will offer you 3D printing services at much lower cost. So that company name is 3Dology. They are based out of Pune. So this is also a website where you have to upload your STL file and their team will analyze the part and they will send you a quotation. So I will share these links on email which you can use to manufacture, I mean for using to get your parts 3D printed. And let me check if the motor body has been downloaded. So I will go to Fusion 360 and I will go to the data panel, and in this data panel you can upload the downloaded model and you can open it in Fusion 360. And the recommended format is step format. In order to open in Fusion 360, I will click on open. Let's wait for a few seconds. It is getting uploaded. And in meantime, I will show you something else. So inside Fusion, if you want any standard fasteners, you don't need to create the nut and bolt of every design. So the standard components are available within Fusion itself. You just have to click the insert menu and you need to say insert MechMaster Care component. And MechMaster Care is a standard website which is integrated into Fusion 360 for all your fastener needs such as screws, bolts, eye bolts, threaded nuts. These kind of components are readily available inside of Fusion 360. You don't need to design them. Let's say I want to insert some screws. So you need to select the system. So I will select the metric system, and in the metric system I want a bolt of 3 millimeters for suppose. I will click on M3 and I will scroll down and I want a length of 8 mm. I will click the length as 8 mm, and further I want a Phillips head. I will select the Phillips head, and I want a stainless steel material. I will select the stainless steel material, and in this also again the various options are there. I will select oval, and the thread pitch is 0.5 millimeters. So M3 by 0.5 mm pitch standard bolt is available, bolt or screw. So you have to click on the product detail, and here you can say 3D step, and you have to click on download, And now you can see that automatically that design is getting imported into your Fusion 360. You can see the CAD model of the screw or the bolt which is readily available, which you don't need to design all the threads and all the small fasteners like this. So readily you can make it using Fusion 360 itself. And then you can directly, once the part is manufactured, you can install it and start fastening the various components of your design. And let me check if it is uploaded. So Part Studio 2, that is the name of the file. You have to use a left click, and using the left click you have to drag and drop that particular component inside Fusion 360, and it is going to open up directly here. So it has opened up. So here you can see the motor is ready for you to use it in your design. So I am going to move it to my particular place and click on OK. And here you can see that in your design tree, the part studio, which is the motor design, is created. I will simply rename this. I will say BLDC drone motor, and I am going to right click here and click on move, and I will move it to the place where I needed it. And I will click on OK. And now similarly I can use the same thing by creating mirror. I will go to create and create a mirror of this. And here object type you need to select as components, and you will select the motor component like this and click on mirror plane. So you need 4 motors. So you don't need to design 4 motors separately. You can simply use the mirror command to create the motor. I will do the same thing to create the other 2 motors. And this time I will going to select this particular plane, which is the YZ plane. And now you can see the 4 motors are being placed here in their positions. So similarly you can download the propellers for the drone as well. Either you can download them or you can create the design. So in tomorrow's class we will do the CFD analysis of the drone propeller, and we will also do the structural analysis of this drone body inside of Fusion 360. And if you have any questions you can ask. So this is a live demo which I wanted to show you in today's class. Any questions? So anyway, today's class is being recorded. That recording I will share with you on email, and you will get certificate after the completion of all the 4 sessions. Any questions, sir?
No, sir. Sir, one thing I want to know, sir, you are making a 3D model in Fusion 360, and and then after this all completion, you are converting in 3D printing.
3D?
3D printer using na after.
Yes, sir. Yes, sir. Once the design is completed in Fusion 360, I am converting the design into STL format and I am 3D printing those components. Yes, sir. Correct.
Oh, so that you are how you are selling that product?
Yes, sir. So once the 3D printing is completed, I am packing it and then I am hosting the product on Amazon, sir. So that's how I am getting the sales. So I am
Oh,
not manufacturing drones as of now. Mainly we are focusing on toys only. So
okay.
on the last day of the session about business and entrepreneurship, we will have a one complete class on that, sir, on day 4. On that day, we will discuss how you can start manufacturing and how you can start selling into market, sir. We will discuss in more detail.
Okay. Okay. Okay, sir.
Okay. Siva Kishan, do you have any questions? Hello? I will show you the 3D printed components also, sir. Today the video quality is not that good, but in the coming classes, I will show you how the 3D printed component looks like, from where I got them, how I am packing them, how I am shipping to my customers. Those things in more detail I will explain, sir. All the steps I will explain.
Okay.
And that's it for today, sir. Then.
Okay, sir. Thank you very much.
Okay. Thank you, everyone. Have a nice day. And
Okay, sir.
tomorrow's class link I will share on email. Tomorrow's class will
Okay.
be in the morning session from 10:30 to 12:30, sir.
Okay. Okay, sir.
Yeah. Tomorrow we will discuss finite element analysis and CFD analysis of drone.
Hmm. Okay, sir. That's great.